Hello, welcome to Omrock Dynamics machine programming language. In our last video, I stressed more on machine programming language, and I also talked about machine programming language being more of binary of 0 and 1 that makes up the entire alphabet of machine programming language. As you know, machines do not understand our human language, so therefore whatever other language that we use for machines that use the normal human alphabet, such as A to Z, 0 to 9, these are interpreted in binary. Today we are going to talk about logic in machine programming language. And logic in machine programming language majorly talks about how machine programming language is implemented, how it is written, and how the machine is able to take whatever instructions that we have given it to perform and translate it in the binary coded decimal processes that enables the machine to understand what we want it to perform. So the machine's programming language is comprised of only two values, that is 0 and 1, which is binary base, which is binary base 2, because binary always base 2, which means that the value is equal to 0, is equal or greater to 0, and less than or equal to 1, but cannot be more than that and cannot be less than 0. So this binary code is what is interpreted, translated, and manipulated into our normal alphabet. So when we talk about machine programming language, it requires a certain degree of logic from our side. That's why I took up a study more on neuroscience, understanding the human brain and the neural system, because on how the human brain works is a little different from how the machine brain works, because the machine brain is the CPU, or the central processor, where all information, all data is interpreted. This central processing unit is nothing but a combination of gates, and when we talk about gates, these are small circuited devices or terminals that are interconnected to perform different various tasks, such as addition, subtraction, multiplication, and conversion. And when you talk about conversion, it's either a negative or a positive, and conversion is that is conversion from negative or positive. For instance, when you're switching on a light or a light bulb, you know, you have to switch it on off, on off, on off, on off. So such logic from our side is what makes machine programming language a little more interesting, and it creates a level of curiosity from your side, a student of programming language. So machines do things in a logically procedural way. How we instruct it, in that manner only that machine will perform. Depending on the kind of instructions we've given that machine, only those instructions will be executed. For instance, if we write a program to add two numbers A and B, and we want to get the sum C, so we define the values for A and B and add them up. But the machine is not going to perform any other task outside those instructions. It's not like an animal's brain, or an animal or a human being, whereby we are dynamic in performing our tasks. We can start doing a particular task, and after a certain process, after a certain level of that task, we decide to change into something totally different, then again get back. It's not like that. The computer follows a procedural process. So which means that machine programming language is a procedural process. It moves from one step to another step, one instruction after the other, and the other instruction guides it to which next instruction is to be given. It does not just do things outside the instruction that it has been given. That is why machines need to be scheduled, they need to be programmed, they need to be maintained, they need to be looked after, they need to be supervised. Because if anything happens outside the instructions being given to that machine, then we are most likely to experience disaster. Therefore, machine programming language became a very, very important way of dealing, communicating, and using machines. Before programming language came to be, we used to deal with hardware directly to perform a particular task. Today we don't need to do that because we have automated machines. This reminds me actually of one more thing I had forgotten to tell you earlier, that there are two kinds of machines we are dealing here. There are manually controlled machines and there are automated machines. Now, the manually controlled machines do not require any kind of programming language. They do not require any kind of instructions being given to it for it to perform a given task. Why? Because all the instructions are given to the user. The person who is controlling the machine is the person who is given the instructions on how to use that machine. But when we talk about automated machines, artificially intelligence machines, such as computers, when we talk about computers, there are various computers, let's say such as laptops or PCs, such need a certain set of written instructions installed upon them, whereby, for example, if you go to your Facebook and you post, you have an option to either post that information at a later date or there and then. So which means that that system has the capability of storing your information until the required date when you want that posting to be posted to your fans. In the same way, machines are being managed by these programming languages. Now, when you take a look at a computer, a typical computer, there are two things you need to understand first before you can sit down and say, oh, I will study programming language. Is first, we have the hardware, the machine hardware, and then we have the machine software. Now, the machine hardware cannot run without the software, because the software is what gets the hardware running, and the software cannot start running unless the user invokes the software to start running. So hardware, software, and the user. The software manages the hardware and the user manages the software. But again, we can make the software to manage itself, and that is what clicks to our mind as artificial intelligence. For instance, when we enable a computer to self-destruct or self-invoke itself, or how do I put this? Okay, let's make it simple. We can make, for example, like I'm using a laptop here, so I can make this laptop to turn on itself at a particular time and date, whether I am around or I am away. As long as once that date clicks and the timing clicks, the machine flashes on by itself. And again, when it reaches a certain period of time and date, it shuts down by itself. That now becomes artificial intelligence. At the same time, we can write a simple code for that using C++ and get it installed into your machine. So machine programming language is used for instructing and developing software that gets the machine hardware running. For instance, operating systems. All operating systems that you see that we install in our computers, in our machines, these operating systems have been written, developed using this programming language. Before C++, C++, which is the most powerful and most common programming language today being used and studied in schools, we used to have Unix. And Unix, our problem is Unix was not more user friendly. It was more difficult to operate it. But when you look at the XP, it was more exciting, more interactive, more user friendly. Even when you're using it, you don't need so much mathematics for you to use the system. You only need to learn to click here, click there, click here, click here, click here to do your information. Click here to manage your documents. It's not like if I remember the first time when I sat behind the computer and it was Windows 98 running, and my teacher opened up the DOS commands and showing me on how to instruct a computer using commands, and everything I had to type, everything I had to type, which was kind of a bit a difficult task, because the time-taking task is different with the click. For you to create, a folder is another process. With those, you have to deal with trees. Even when you want to look for a particular piece of data that you already installed in your machine, it takes time. You have to follow the tree structure for you to reach the real child node that you want. So machine programming language became more popular. It's not that some people say you need mathematics to be able to understand machine programming language. Yes, you do need it. At some level also, you may not need it that much. Why? Because learning high level language is just as you decide to move from Africa and you come to Asia and you start and you learn how to write their alphabet. Because if you see how they write their alphabet or their vowels, their handwriting is totally different from the normal Roman English way of writing. It's a bit complicated there, it's artistic. It's like that, when you're trying to learn a new language. But machines were more simplified, communicating to them were more simplified. Like in the previous historical machines where we had to write a series of binary code for it to perform particular task. And a small task, you have to write an essay of instruction of only 0 and 1, 0 and 1, 0, 0, 1, 0, 0, 1. It becomes difficult to manage, difficult to maintain, and difficult to remember the instruction, because it's a long binary code. It's a very, very long binary code for for us to remember, and we have to write every code down for future references in order not to make ourselves stressed up a lot. So binary is converted into the normal human understanding. How do we do this? For instance, the human alphabet A to Z is represented in machine binary code, and it's installed inside the machine. Now inside the machine, it knows that A has a binary value, B has a binary value, C, D up to Z all have binary values. Now those binary values are connected to the hardware keyboard, which is the input. So when you click a button, that button is actually not the alphabet letter that you see written on that button. For example, you're pressing B, but it's not actually B, because the computer does not know B. It only knows the binary value of that letter B. So when you press B from the machine, it looks for a value that represents that particular key button, and once it reads out the binary value of that key button, it displays for you a B. For instance, if you turn on a switch on, the light flashes, the bulb switches on, and when you switch it off, the bulb goes off. But from the background, it is actually electricity that gets generated. Once that electricity reaches the bulb converts that energy into a light, into something that burns, that shines, to give you the desired result. So binary coded decimal is the machine programming language alphabet. If you understand binary very well, you know how to add, subtract, and manipulate binary values. It's very, very helpful. Thank you very much. Till next time, we'll look at something else much better on logic in machine programming language. My name is Oparok Emmanuel, bachelor degree in computer applications, and currently studying a master's in computer application, and also conducting a research in neuroscience that is trying to understand the human brain and machine programming language in robotics. Till next time, thank you for supporting Omrock Dynamics.